factoring binomials. So the steps for factoring binomials, a little bit different when it comes to standard form. Most of them will be in standard form, which is fine, but if they're not in standard form, for some reason this author does not want you to put them in the standard form. Factor them the way they are. We still need to check for greatest common factors though. And then there's only 3 methods to factor binomials, 3 different rules. If one of these 3 rules does not work, it cannot be factored. The first method, and by far the most common method or rule, is called the difference of squares. Here, both terms are perfect squares, terms that you can take the square root of, and it works out to be a whole number integer, and it simply is going to factor into the binomials a plus b times a minus b. Next, the difference of cubes. 2 terms that are perfect cubes you can take the cube root of that are being subtracted. You're going to factor this into a minus b times a squared plus ab plus b squared, and the sum of cubes. 2 perfect cubes that you're adding together, sum of cubes, and it's going to be factored into a plus b times a squared minus ab plus b squared. So notice there's no such rule as the sum of squares. We have the difference of squares, 2 terms that are perfect squares that are being subtracted, but if there are 2 perfect squares that are being added, it cannot be factored. There's no such rule as the sum of squares. So example 1, x squared minus 64, yes, is in standard form, no greatest common factor, so only 2 terms. We want to then identify, are those terms perfect squares, perfect cubes, or maybe now they're 1. X squared obviously is a perfect square, the square root is x. 64 is actually both a perfect square and a perfect cube, but since the first term was a perfect square, we'll treat it as a perfect square as well. The square root 8, so difference of squares, we are subtracting these 2 perfect squares, so it just simply is going to factor into the binomials x plus 8, x minus 8. So we have 2 factors, it is completely factored, but every now and then, now that we are learning how to factor binomials, we'll factor once and then may have to factor again, because our factors in most cases, as we see, are binomials. So take a quick check and make sure it is completely factored. Example 2. It's in standard form. We do have a greatest common factor 3. We factor it out. It gives us 3 times a squared minus 25. Still a binomial inside the set of parentheses. A squared obviously is a perfect square. Square root is a. 25 perfect square. Square root is 5. And once again, we are subtracting them. So a squared minus 25 is going to factor into a plus 5 times a minus 5. Not forgetting to bring down the greatest common factor 3. So 3 things being multiplied is completely factored. We have a total of 3 factors. Example 3, it's in standard form, no greatest common factor. 2 perfect squares, the square root of x to the 4th is x squared, the square root of 1 is simply 1, and obviously we do have subtraction. So difference of squares is going to factor into x squared plus 1, x squared minus 1. But what we should notice at this point is that these 2 terms, x squared and 1, are still perfect squares. So in the first factor, 2 perfect squares, but we can't do anything with it because of that plus sign. There's no such rule as the sum of squares. However, the second binomial, the second term or factor, the square root of x squared is x, square root of 1 is 1, and we are subtracting, so we need to use the difference of squares again. Just on that, second binomial is going to factor into x plus 1 times x minus 1. So simply bring down the first factor, that x squared plus 1, and now we're completely factored. We have a total of 3 factors, 3 things being multiplied, x squared plus 1 times x plus 1 times x minus 1. Example 4, it's in standard form, no greatest common factor, so 2 terms. Identify if the terms are perfect squares, perfect cubes, or it could be neither one. 64r cubed is a perfect cube, the cube root is 4r. 125s cubed, perfect cube, the cube root, 5s. And since we have subtraction, we're going to be using the rule, the difference of cubes. So binomial is simply going to be 4r minus 5s times the trinomial, 4r squared plus 4r times 5s plus 5s squared. Just by substituting the values for a and b into the formula. You certainly need to go back and simplify a little bit. 4r squared gives us 16r squared plus 20s plus 25s squared. Now we have a total of two factors, a binomial and a trinomial, but they're still being multiplied, so they're still factors, and it is completely factored at this point. Number 5. Two terms, it's in standard form, no greatest common factor. Y to the 12th is both a perfect square and a perfect cube. It's a perfect square because the exponent is even. It's a perfect cube because the exponent is divisible by 3. So since 125 is a perfect cube, we're going to take the cube root of y to the 12th, divide that exponent 12 by 3, it gives you y to the 4th. So two perfect cubes that are being added together, so now we're going to use the sum of cubes. The binomial, y to the 4th plus 5, times the trinomial, y to the 4th squared, minus y to the 4th times 5, plus 5 squared, which simplifies to y to the 8th minus 5 y to the 4th plus 25. Example 6, two terms, standard form, no greatest common factor. X to the 8th is a perfect square, the exponent divisible by 2. 9 is obviously a perfect square. However, those two perfect squares are being added together, which means we cannot factor it. It's prime. Example 7, we notice, is not in standard form. This is an example what I was referring to earlier. Even though it's not in standard form, we're not going to put it in the standard form. We're going to factor it the way it is, which actually is a little quicker. No greatest common factor still. Square root of 121 is an 11. Square root of t to the 4th is t squared. Obviously we have subtraction, so difference of squares. 11 plus t squared times 11 minus t squared. And example 8, two terms, standard form. We do have a greatest common factor of 4, so we factor it out. We're left with 4 times x squared plus 25y squared. Still two terms, then the terms themselves are still perfect squares, but once again, since that's a plus sign, we cannot factor the binomial. Now we would not call this problem prime because we have done some factoring. Prime means you cannot factor or do anything to the original problem. Factoring out a greatest common factor is factoring. It just simply means this is all the factoring we can do, or it's fully factored at this point.